Welcome back. Today we're going to take a look at the remainder theorem. I will point out that it is a little bit more theoretical than some of the stuff we've done. The math's not that tricky. It's just a little tricky to comprehend why we're doing what we're doing. So try not to get too bogged down in that. Let's just learn how the math works. And I will tell you that this is the basis for the next few lessons, so it is fairly important. Without further ado, let's begin. In order to use the remainder theorem, we have to talk a little bit about long division. We're going to start off with the easy type, the type that you learned back in, I don't even know if they do this in elementary anymore, but we're going to learn it now. To manually do division, here's what we want to do. We have, for example, 1a. Bring up the pen. We're going to start off with just the 85 instead of the whole 857. And what we want to do is find out what's the most number of 21s we can fit into 85. And hopefully you'll realize that it's 4 of them. So what I'm going to do is put 4 there, and 4 times 21 is 84. 85 minus 84 is 1. Bring down the 7 to make 17. I now get 0 21s out of 17. So 0, 17. So the way that we would normally say that is that we would have a quotient of 40 and a remainder of 2. So I actually have it over here. We got the quotient and the remainder. So that means we get 40 21s out of 857, which actually multiplies out to 840, but we got 17 units remaining. Okay, let's try that again for the second one. For 17, we're only going to look at the first 2 digits, 28. How many 17s can we get out of 28? The answer is just 1. 1 times 17 is 17. 28 minus 17 is 11. That number that we get should always be smaller than what we started with, like the 17, because if it was bigger than 17, we could have gotten more 17s out. Now I'm going to bring down that 5. How many 17s can I get out of 115? 5 of them would be 85. 6 of them would be 102. Yeah, I think that's as many as we can get. 6 times 17 is 60, plus 42 is 102, and our remainder is 13. So we have a quotient of 16 and a remainder of 13. We get 16 entire 17s out, and we have 13 things left. So, for instance, just to make this a little bit more concrete for those who are struggling with the concept, if we had 285 people and I said I want you to make groups of 17 out of them, I could get 16 entire groups of 17 out, and I'd still have 13 people left that had no group. Okay, for part C, how many 13s can we get out of 35? Well, 3 times 13 would be 39, so not quite 3 groups, but we can get 2 out. 2 times 13 is 26. After the 26, we have 9 remaining. So I bring down a 4. How many 13s can I get out of 94? I think the answer is 7. 7 13s would be 91. That leaves us with 3. Bring down a 1. How many 13s can I get out of 31? The answer is just 2. 2 times 13 is 26, and I'm left with 5. So if I had 3,500, my dyslexia is coming out, 3,541 people wanted to divide them in 13 groups, I could get 272 groups, and I'd still have 5 people left. All right, so that's how long division works with numbers. Again, you may or may not have done that in elementary. I think you still do, but yeah, elementary people are weird. I have no idea what they're doing these days. Now we got to see if we can do this with binomials and polynomials. Okay, I will point out that this is a little bit mind-boggling at the second. Just don't worry too much about it. It's not really important that you memorize that or anything. It's just the idea that, going back up here, when you take a number like this, divide it by that, this is how many holes you get out, that's what's left. This is just a fancy equation that says exactly that. I'm going to erase those because it made a mess of my equation up there. So here's what I want to do. I want to take the polynomial x squared plus 8x plus 19. I want to divide it into x plus 3's, and I want to see if I've got, or how many x plus 3's I can get out and what the remainder will be. Now this part here, very, very like hypothetical. It's not at all concrete. What's the term I'm looking for? It is abstract. It is an abstract idea. But again, the math isn't that hard. We just have to understand the process. Okay, so here's how we do it. I look at just the first term, the x squared plus 8x plus 19, but just the first term, x squared, and I want to multiply something times the x to get the x squared, and it's going to be a 1. An x. So I have 1x. And in much the same way that up here, I put it over the last piece, here I'm going to put it there, the x over top of the 8x, so that anything over top of a term is the same power of x. Again, this is the first one we're doing, so it may seem a little bit weird. Just kind of follow along, and hopefully after 2 or 3 it'll make sense. I'm now going to multiply that x times the x plus 3, and that gives me x squared plus 3x. Okay, that wasn't too bad. Now I'm just going to subtract those, and I'm left with 5x. I'm going to bring down the 19. And how many x's can I get into 5x? The answer is 5. So now I do 5 times x is 5x. 5 times 3 is 15. And I'm left with 4. Okay, so just kind of like before, this number up here is our quotient. The number of holes, if you will. And I realize it's weird to say holes when you're talking about a variable, but that many holes, and that's the remainder. So the dividend divided by the divisor is equal to the quotient plus the remainder over the divisor. So just to go up for 1 second, here we would say we had a remainder of 17, which is really 17 21ths left. Here we had 13 17ths, and here we had 5 13ths. So here we'll have 4 x plus 3's, 4 over x plus 3. Again, it's kind of weird, but yeah. We still have to divide the 4 by the x plus 3 because we haven't done it yet, is essentially it. So it's going to end up being a weird fraction. Okay. Mechanically, let's see if we can do the next one, even if we're having a hard time really gripping what it means. I see that there's a 6x squared starting off my dividend. So in order to get a 2x, I'm going to have to multiply 2x by 3x. So I'm going to put a 3x here. 3x times 2x is 6x squared. 3x times negative 1 is negative 3x. Now be careful on the signs here because there's a negative there. The 6x squared minus 6x squared goes away. 11x minus negative 3x is 11x plus 3x is 14x. Bring down the minus 12. Now, in order to get 2x to become 14x, I'm going to have to multiply by 7. So I'm going to say plus 7. 7 times 2x is 14x. 7 times negative 1 is negative 7. And now I do 14x minus 14x is no x's. They go away, which is kind of the reason we chose the number we did. And negative 12 minus negative 7, which is negative 12 plus 7 is negative 5. So this may seem weird because our remainder is actually a negative number, but that's okay. We're allowed to have that. So we can say our quotient is 3x plus 7, And our part at the end would be a remainder over divisor, negative 5 over 2x plus or minus 1. But the remainder itself is just the negative 5. Okay, if you can do part C, you are the ruler of all things and the king or queen of knowledge. Okay, so to multiply 3x by something to get 3x to the fourth, I just multiply it by x cubed. I'm going to put it over top of the x cubed term, just so that it lines up nicely. X cubed times 3x is 3x to the fourth, which is good. We want that to be the same, so it cancels. X cubed times 5 is plus 5x cubed. Subtract second polynomial from the one above it. The 3x to the fourth goes away. 17x cubed minus 5x cubed is 12x cubed. Same thing. What do I multiply 3x by to get 12x squared? And the answer is 4x. So plus 4x. 4x times 3x is 12x squared. Oh, I forgot. I need to bring down my... Oh, sorry, this should be cubed. It should all be cubed. And that should be squared. Now I bring down my 11x squared there. 4x squared times 5 is 20x squareds. Subtract those. 11 minus 20 is negative 9x squareds. Bring down the minus 9x. To get from 3x to negative 9x squared, I multiply by negative 3x. So that gives me negative 9x squared. Negative 3x times 5 is negative 15x. The first terms cancel each other out. Negative 9 minus negative 15 is negative 9 plus 15 is 6x. Bring down the plus 13. And to get 3x to become 6x, I have to multiply by 2. 2 times 3x is 6x. 2 times 5 is 10. Remainder is 3. So quotient is x cubed plus 4x squared minus 3x plus 2. And the remainder is 3. So another way to think about that is if I divided that big polynomial by the binomial, 3x plus 5, this is the number of whole groups that I would have, and this is how many pieces I have left that didn't fall into a group. Okay, I'm going to point out that you can rearrange the equation that I gave up here and get that, which means that you can always go back, multiply through. So you could always multiply these two things together and then add that down there. And when you do that, you should get back to this big long polynomial that you got in the first place. In much the same way that with any of these, if you did 17 times 16 plus 13, you should get back to the 285 or whatever. All right, so that is rather tedious, but there is actually a method that we can use to find remainders without dividing. Check this out. Here we have our function, f of x equals x cubed minus 3x squared plus 14x minus 8. Let's just plug in a whole bunch of different values for x and see what we get out. Okay, so f at 0 equals 0 cubed. Oops, that should be a minus. 0 cubed minus 7, 0 squared, plus 14 times 0 minus 8. And I think you can probably see that that's just going to be minus 8. Why we're doing this, I'm not going to tell you yet. You have to wait a second. But just bear with me. Right now, we're just going to plug in numbers and see what happens. If I plug in f at 1, that's 1 cubed minus 7 times 1 squared plus 14 times 1 minus 8, which is 1 minus 7 plus 14 minus 8. It's minus 6 plus 8 minus 8 is 0. Okay, so when I plug in 1, I get 0 out. When I plug in 2 2 cubed minus 7 times 2 squared plus 14 times 2 minus 8 is 8. 2 squared is 4 times 7 is 28 plus 28 minus 8. Actually, everything cancels out. We get 0 again. One more time. Well, actually, 3 more times. I lied. 3 cubed minus 7 times 3 squared plus 14 times 3 minus 8 is 27 minus 7 times 9 is 63 plus 14 times 3 is 42 minus 8. My brain's starting to hurt a little bit with these numbers, but I think that's going to give me 27 minus 63 is 36. 36 plus 48 is 78. I think it's 70. Hopefully I didn't mess up that one too badly.
Oops, little edit here. I need to get rid of that answer. My brain apparently was doing negative 27 plus 63. When we put these together, I think you get 69 minus 63 is 6 minus 8 is negative 2. So we'll use that as our answer here. Sorry to interrupt.
Plug in a 4. 4 cubed minus 7 times 4 squared plus 14 times 4 minus 8. 4 times 4 is 16 times 4 is 64. 16 times 7, 70, 112, I think, plus 56 minus 8. Okay, and when I put all of that together, I get 0 because I paused it, used my calculator because my brain is breaking. I'm good at math techniques. I'm basic stuff like this is just it's a waste of time, waste of brain power. Okay, final one. 5 cubed minus 7 times 5 squared plus 14 times 5 minus 8. It's 125 minus 175 plus 70 minus 8. And I think if I rearrange those quickly in my head, I get negative 50 plus 20, this is 12, or something like that. Okay, so we plugged in a bunch of numbers, we got a bunch of answers. Who cares? What difference does it make? Here's a neat little thing. If you factor this, that original polynomial, get that out of the way so you can still see the title, you get x minus 1, x minus 2, and x minus 4 as factors. 1, 2, and 4. 1, 2, and 4. What do those all have in common? And the answer is when I plugged in the values 1, 2, and 4, which are the roots or the zeros of the function, I get out 0 remainder each time. That's extremely helpful. So what it's saying is if I plug in a number, any number, and I get out a 0, I know that that's one of the divisors. That's one of the factors of my equation, of my function in this case. And that becomes a formula. Now, by the way, the rest of these are the remainders. If I divide by, get my marker back here, come back, stop bouncing. Okay, if I do x, which is the same thing as x minus 0, if I divide the polynomial by x, my remainder is negative 8. If I divide it by x minus 3, the remainder is 70. And if I divide it by x minus 5, the remainder is 12. That's super handy. And that actually is our remainder theorem. If you take any polynomial, p of x, divide it by x minus something, the remainder is just going to be that polynomial at that something. So if I divide it, for instance, at x minus 7, then I get the remainder by plugging 7 in and just evaluating the equation. Now, for the second part, this part seems a little bit weird or a little bit longer. If I want to divide a polynomial by a binomial where the coefficient's not 1, it's something else, so in this case, ax minus b, then I have to plug in b over a to get the remainder, which makes sense because if you think about it, if I plugged in b, that tells me the factor, the remainder when my factor is x minus b. Well, ax minus b is really the same thing as ax minus b over a. So it's really just the exact same rule up here. You just want to plug in that to find out the remainder when you divide by x minus that. The a in the front doesn't really do anything. Okay, so I realize this sounds all hypothetical and theoretical and abstract, so maybe let's try this out. Let's use the remainder theorem to find the remainder when the polynomial 2x to the power of 4 minus 11x cubed plus 12x squared plus 5x minus 17 is divided by x minus 4. Now, there's two ways we could do it. One way, we can use long division, which will take many steps and has lots of opportunities to make little errors. Or we can say, let's evaluate that at x equals 4. And when we do that, we get out 2 times 4 to the 4th minus 11 4 cubed plus 12 4 squared plus 5 times 4 minus 17. Not that this is particularly short, but it's a lot faster than the long division. Okay, I'm going to pull out my calculator here. I'm not even going to pause because I think I can do this quick enough. 2 times 4 to the power 4, which is 256, is going to be 1024. 4 to the power of 3 times 11 is 704. 4 squared times 12 is 192 plus 20 minus 17. And then 1024 minus 704 plus 192 plus 20 minus 17 equals 515. Okay, so that's our remainder. Was it hard? Not particularly. We literally just plugged in a number. It was a little bit of algebra, but nothing really difficult, just a little tedious.
Little edit in 4a again. I goofed right here. This shouldn't be 1024, it should be 512. And that means that this final answer should be 512 smaller. That should be a 3. My apologies.
Let's try that again for dividing 6x cubed plus 7x squared minus 7x plus 6 by the binomial 2x minus 1. Now here what we want to do is we want to plug in x equals negative 1/2. X equals positive 1/2. Since this is ax minus b, and we're doing b over a. Okay, so when we plug that in, we get 6 times 1/2 cubed plus 7 times 1/2 squared minus 7 times 1/2 plus 6. Okay, 1/2 cubed is 1/8. 6 times that is 6/8. 6/8 is the same as 3/4. You are welcome to use decimals here, but I actually think it's faster if you use fractions in this case. 7 times 1/2 squared is 7 times 1/4, 7/4. Minus 7/2 plus 6. 7/4 plus 3/4 is 10/4. 10/4 is 5/2. Oops, minus 7/2 plus 6. 5 halves minus 7 halves is minus 2 halves is minus 1. Minus 1 plus 6 is 7. And again, that's the remainder. Okay. There are some homework questions. Oh, the read part. You don't have to read that. Ignore that. I'll take that off your actual downloaded file, but for now, just realize you don't have to do that. There are some questions there. None of them take too much time, so give it a shot. Now, I will point out that it says to verify your answers with technology or a computer algebra system, which we haven't talked about yet. But what you can do is use something called Mathway, which is just mathway.com. And if you want to stick around for just a moment now, I will take you to mathway.com and show you how it works. If you don't want to watch it, you can go try and figure it on your own. Completely up to you. Okay, so here we have mathway.com. Just says, how can I help you? So here's what we're going to do. Oh, I guess I have to accept cookies, which is not a problem. I always accept cookies. Okay, so let's actually just do the last one that we did and see how it works. We want to use the function. I'm just going to put brackets around the whole thing so it doesn't get confused. Be careful about how you punch it in. It's a little bit like equation editor, but yeah, you'll see. So we want to punch in 6x cubed plus, actually, I guess I don't have to use brackets there. 6x cubed plus 7x squared minus 7x plus 6. And then I want to divide that, and you'll see that it automatically jumped to it. Now the bracket's unimportant, but it was needed to make sure that it set it up correctly in the first place. And I want to divide that by 2x minus 1. Okay, so I've typed in my polynomial. I'm dividing it by the binomial. And now I'm just going to click on this button over here, and it's going to ask me all these different things. And I'm just going to plug it or hit find the remainder. And it says right there the remainder is 5, which, why did we get 7? Oh, I know why we did. Let's go back real quick. Because apparently, oops. Oh, there we go. Apparently I can't do basic math. And if you guys were here, you would have called me out on this, but you weren't. You were probably yelling at your screen saying, Mr. Ray, don't be an idiot. 5 halves minus 7 halves is negative 1 plus 6 equals 5. This is why we check using technology. Because of all the complex math that I did there, and this thing I screwed up was a minus sign instead of a plus sign. Oop, what the heck just happened there? Okay, we're back. Okay, so the good news is Mathway did help us do that. And now it wants me to sign up and pay them. We don't want to do that, so we'll just close it. Tap to view steps. Oh, it wants me to pay them, so I'm going to close it. Now I will want to tell you, if you made a small typing error, instead of typing the whole thing from scratch again, here's a little trick. You just click on it over here in the blue, and it will bring it back in. So if you meant to do 2x like plus 1, then you can say, okay, tell me the remainder of that. Find the remainder. And it'll do that for you. So that's just a little trick. Use that if you want to plug in the same equation more than once. You click on it over here, all it does is it wants you to log in and pay them. Anyway, pretty cool site for doing some algebra, or at least double checking your algebra fairly quickly. I would recommend coming back here when you feel like you need it. Anyway, I'm going to stop there. Let me know if you got any questions. Make sure you try those homework questions, and then I'll see you in the next lesson. Have a great day.